Okay, so yeah, for today we are going to start with chapter 10, which deals with gases. So, what do you think about gases? Like you can see oxygen, nitrogen, hydrogen in atmosphere. So, what do you think? What are gases, and what should be the properties of the gases? You can open your mic also. Okay, if you are having any issue or anything, you can ask me directly by opening your mic. Okay, no problem. Okay, no problem. I will. For those students who have already paid the amount of our classes, if they will leave some session due to some problems, I will be able to provide you the recorded session. But the recorded session will be, it will have a kind of restrictions that only those students which I will allow, only they can see, otherwise no one can. Okay, so don't think that if I'll record and I'll send and you will be able to share to everyone, so there is no need to pay. It's not like that, right? So it is like, I will, inshallah, I will share the recording for those who have purchased the premium plans. Okay, fine. Yeah, so yeah, the one Amna says that it is a easy flow. Okay, fine. If it is flowing, okay, for example, anything is flowing. What do you understood from flowing? For example, let us consider you are having a glass of water. Okay, a glass of water, and you added sugar inside it. So what will happen? What will happen? The sugar will dissociate, and everywhere sugar, and at the end what will happen? It will be dissolved. Why it will be dissolved? Did you think? Did you try to imagine why this that is dissolved, that sugar is dissolved inside the water? Why? For example, I have this hand like this. Okay, like this. I want to put this my hand inside this. Is it possible? To tell me, if this is my hand, I want to do it like this. Is it possible? Obviously not. But for example, if I will open like this and I'll try to do this, now it is easily possible to penetrate the particles, right? So what does it mean? It means that the particles do have the spaces inside them, the spaces between them, so that the particles are able to completely dissolve in each other. Okay, all the process is called diffuse in each other. Okay, so if the particles are intermixing, it means that they have distance between the molecules. Okay, first thing. The second thing, if we talk about the gaseous particles, so gaseous particles, they are very energetic. Energetic in what sense? For example, there is a big room. Okay, for example, you are sitting in library. Let us consider you are in university and you are in library. And in library, someone bring a fried chicken. Okay, someone bring a fried chicken with a very tasty smell, and she is sitting at the corner of the library. So think what will happen. Will you be able to smell that? Tell me, will you be able to smell that? Someone is having a very tasty chicken, fried chicken, and it's in the library, and obviously you will be able to smell that, and you will feel, oh my god, now I'm feeling hungry, right? But what if someone is eating an ice cream? Let us consider a mango ice cream or any ice cream at the corner of library. Will you be able to smell the ice cream at the different corner of library? No. The reason, what is the reason? The reason is the temperature. If the temperature is large, means hot chicken fry, so what will happen? The particles of the gas, they will run each with random motion. And if they will run with random motion, what will happen? They will spread inside in our atmosphere. But if the temperature is less, ice cream, so what will happen? The particle will not go with very high speed. Okay, so that random motion, that means that the particles of the gases, they are in continuous random motion. That's what I wanted to tell you. The particles of the gas, they are in continuously random motion, and the process of spreading the smell of anything, that is called diffusion. Okay, so these are the foundations of the gases chapter. Here for these classes, I will share with you some questions also, because I think yesterday there was an exam of UAE university students, and the syllabus is just same as yours. I have the question papers of them, and wallah, everything is from your syllabus, everything. Inshallah, we will solve those questions also, don't worry. Right, so okay, so let's start with the main topics of our class. The main topics are these: Boyle's law, Charles and Gay-Lussac law, Avogadro law, and combined gas law. This will be our main focus for today's class. Now, what does law means? Okay, law of motion or any kind of law, what does it mean? Law, what do you understand by law? Remember, law is that thing which can be shown mathematically. Law can always be shown with the help of mathematics. See, let us consider, if we talk about the Boyle's law, this one, the Boyle's law. So Boyle's law, what does Boyle's law say? The Boyle's law says that whenever you will increase pressure of anything, so the volume will decrease. It is the very simple thing. Wallah, it is wallah very simple thing. See how very simple thing. For example, there is a container, okay, and for example there is a gas particles inside this, and there is a piston here. Okay, so what you did, you increase the pressure. Okay, so you increase the pressure. So what you did, you just put force inside this. So what will happen? It will go here, and the volume of the container will, tell me in the comment box. And if I will increase the pressure, if I will put more pressure on the piston, so the pressure will the volume will decrease. Very good, the volume will decrease. That is Charles law. Khalas, simple. That is the Charles law. So Charles law says that, oh sorry, it's not Boyle's law. Okay, so Boyle's law. So now what I can do from here, from this observation, what I can do, I can write this: if the pressure is increasing and volume is decreasing, this relation is called inversely proportional. Inversely means opposite, okay, and proportional means related. Okay, so it is inversely means oppositely, and proportional means related. They are oppositely related. If one thing will increase, second thing will decrease, like that, right? So what will happen now? I can do like this: the pressure is inversely proportional, should be like this. So pressure is inversely proportional to volume. This is called the Charles law. And when it will happen, what are the conditions for the Charles law? Remember, see, for example, I want to know, let us consider, one second, yeah, for example, I want to hear the voice of any of you student. What's happening here? I think the whiteboard is not visible. Yeah, it's now visible. So tell me, there are 4 students in the class. Let us consider. Okay, I want to listen the voice of let us consider any student. Let us consider Amna. I want to listen the voice. What I will do, I will make Fatima, Mahara, Sara, everyone silent, so that I will be able to listen the voice of one student. Okay, I want to know the change. I want to know the voice of one student. So, and let us come back to our topic. For example, if I want to check the relation between the pressure and volume only, I want everyone to become silent. Okay, so what will happen? If I want to make them silent, what I will do, I will put the number of moles, the temperature, they will be constant. So if I want you to tell me my friend, what is the Boyle's law? So you will say Sir, at constant number of moles and constant temperature, the pressure is always inversely proportional to volume. Okay, that is the definition of the Charles law. So fine, so it come here, and right now what we can do, let us consider we are having P is inversely proportional to V. When I want to remove this sign, we can put P is equals to K multiplied by 1 by V, where K is a constant. If I want to put equals to in the place of this directly proportional, I'll put a constant here. So what will happen, I will just multiply V by both sides. It will be PV equals to constant. So remember, always remember, my friends, always remember, pressure and volume multiplication will always be constant. Always be constant. Okay, so for example, I have a gas in this container. Okay, and let us consider right now the piston is just above here. Here is the piston, and volume is the V1, and let us consider the pressure is P1. I put some pressure here. Okay, so this beaker will be like this, and the piston is now here. Okay, and here are the molecules, and this is the volume is V2 and the pressure is P2, because both things are changed. So I told you, my friends, I told you what? When the temperature and number of moles are constant, did I change temperature? Tell me, did I change temperature? No. Did I change in the number of moles of gases? No. I only change the pressure and volume. So when we talk about the pressure and volume, so always remember, for a gas, P1 V1 will always be equals to the P2 V2. Always. Okay, did you understood my point? You cannot hear my voice? You cannot hear my voice? Oh, there was some problem in between that? Oh, okay, fine. So did you understood this? How P1 V1 equals to P2 V2? Because P1 V1 is constant, P2 V2 also constant, P3 V3 also constant, P4 V4, everything is constant. It means P1 V1 equal to P2 V2 equal to P3 V3, and so on. Pressure and volume multiplication will always be constant. Remember that, and you will be able to put is equal to like that. Okay, now a question for you guys, a question for you. For example, I have a gas at 1 atm, 1 atmospheric pressure, having volume of 250 milliliters. Okay, at 1 atm the volume is 250 milliliters. I want you to tell me what will be the volume at 2 atm pressure. Tell me fast. Volume at 2 atm pressure. Very good, 125 ml. So remember, this Boyle's law question will definitely come there. Okay, and also there were many questions regarding this in the Alex also. Okay, if you want, I can open the Alex of any student. If you want, I can open the Alex for any student, and we can solve the questions there also if you want. But fine if you understood it, everything. Okay, so you can tell me if you want. I can open the Alex and we'll be able to solve everything. Right. So let's let's go to the next topic. Okay, so the first one was Charles law, and Charles law is now a piece of cake for you. Okay, for you, Charles law is now a piece of cake. You can enjoy it very well. Okay, now the second one. See, Charles law. What does Charles law says that? I want you to tell me. I want you, everyone. I want you to tell me. For example, I have a gas, okay, in this container. We are studying right now Charles law. Okay, for example, we are having this container and there is some gas here. Let us consider this is any gas here. If I put some burner inside it, burner means fire. I put fire here. So what will happen? Obviously, the temperature here I give temperature, so temperature will increase. If I increase the temperature, tell me guys, what will happen to the volume? If I will increase the temperature, what will happen to the volume? See, again think again. For example, you are having water and you are boiling it. So you will increase temperature. At the end, what will happen? It will completely convert into the gas. It will expand. Think. If it will expand, the volume will increase. Okay. If it will expand, obviously the volume will increase. And if the volume will increase, what we can relate like this: if I am increasing the temperature, the volume is also increasing. So I can say that the volume is directly proportional to temperature. If I am increasing the temperature, the volume will also increase. Okay, so now for I have to put some constant, so it will be like V will be equals to KT. K will be a constant, right? Now what will happen? If I have a different volume, and it will be a constant. I just divided everything by T. So V by T will be equal to K. Now I can be able to judge them like previously I did. See, it was equals to a constant. If anything is equals to constant, what will happen? Tell me, if anything is equals to constant, so what will happen? If anything is equals to constant, so what will happen? If I will change them, they will be exactly like this. So if I change them like this, like V1 by T1 equals to V2 by T2. This is the second one, the second law which can be used here. One thing remember, I told you, if I want to listen the voice of any one student, I have to silent every other. So here I want to know the difference in the volume and temperature. So I will put number of moles and pressure constant. Okay. One thing you remember, my friends, the volume, it can be in ml, centimeter cube, in liters. It's your wish for these questions. Okay. But for temperature, it must be in Kelvin. It is must in Kelvin, not in the Celsius or Fahrenheit. Never. Temperature will always be in the Kelvin. Okay, so let's try a question related to this. So the first question is the question 2. The question 2 says that the volume of a gas was found to be 25 milliliters, just write 25 liters at 300 Kelvin. Okay, what will be volume at 600 Kelvin? Tell me. Very good. 50 liters. Great. Exactly. The answer is 50 liters. Okay, so this is how we will be able to check, and we will be able to solve these types of questions. Just a second. I have a question for you from the PDF of the slides which your doctor had done in the classes. Read the question. If a skin diver takes a breath at the surface, filling his lungs with 5.82 liters of air. Okay, this volume is where? This volume is here at the surface. Obviously, when the skydiver, he will breathe in the surface, I mean in the atmosphere. Okay, and what will be the volume of air in his lungs occupy when he dive into the depth? You know that when you will go inside the water, what will happen? The pressure will increase. So, and they are telling you, they are telling at the constant temperature pressure, the pressure at the surface is 1 atm. So P1 equals to 1 atm, V1 equals to 5.82, okay, and the P2, it's equals to 1.92. What will be the answer of V1? The V2. What will be the answer of V2? Calculate, please. Do calculations. What will be answer of V2? Check the formula which you have to use. First, check the formula, my friends. Check the formula. Which formula you used? Tell me. Which formula you used? Yes, very good. Yes, very good. The answer is 3.03. And the formula used is P1 V1 equals to P2 V2. Okay, it's very simple. Okay, let's move to another question. The sample of the argon occupied this much volume of the argon at this temperature. What will be the new volume at 50 degrees Celsius? Tell me. Please do calculations. First tell me which formula you are using. Guys, if you are fine with the opening mic, you can open your mic, it's not a problem. Okay, because while talking you can be able to solve them easily. Yeah, Charles law will be used here. And tell me what will be the answer here. Okay, 15.82. Very good. The answer is 15.82. How you did this? What will be the unit of the temperature will be used here? What will be the unit of temperature you are using? Kelvin. Very good, Kelvin. Yeah, right. So guys, are you able to understand? I have received only 2 yeses. Yeah, okay, great. So let's move to another law. The last one is for you. The last one is Avogadro law. Avogadro law. What is Avogadro law? Remember one thing, whenever you see the name of Avogadro, this scientist, always remember, my friends, the name of the Avogadro comes always with the number of moles. And this is very simple. And wallah, this is very simple. How? See, tell me, I have 1 mole of hydrogen gas, and in this balloon, let us consider this balloon, and in this balloon I have 5 moles of hydrogen gas. So tell me, whose volume, this is V1, this is V2, whose volume will be bigger? Whose volume will be bigger? I have same gases, everything is same, I just increase the number of moles. Number of moles means the particles. It have 1 mole, it has 5 moles, simple. The number of the particles, I increase 5 times the number of the particles of the hydrogen molecule. So which one will have a greater volume? It is very simple. Yes, V2. How about the other ones? Are you having any problem that V2 should be, or it should be V1? Exactly. Yeah, V2. Right. So it is the very simple thing you got. If I will increase the pressure, if I will increase the number of moles, tell me, if I will increase the number of moles, what will happen to the volume? If I will increase the number of moles, what will happen to the volume? Very good, the volume will increase. So simply we can yes, very good. So simply we can write this, the volume is directly proportional to the number of moles. Simple. Now volume will be equals to Kn, and V by N equals to V by N, where it is V1 by N1 equals to V2 by N2. And this is the simple thing, very simple thing. Okay, very simple. One thing, my friends, one thing always you remember, always, that at standard temperature and pressure, standard temperature pressure means standard temperature is 273 Kelvin temperature, and the pressure is 1 atm, 1 mole of gas equals to 22.4 liters volume. This is always, this is wallah always, this is very important thing, because you know, I can, if you know this 1 mole of gas at 22.4 liters at STP. Okay, now see what you can do now. I have a question for you. I have 44.2 8 liters of hydrogen gas at STP. Tell me number of moles. Tell me how much moles will it have? I gave you the volume. Okay, sorry, Zoom has some problem with 40 minutes. You already know about that. So tell me, what should be the answer? If 1 mole of gas is 22.4, then 44.8 should be how much? How much moles? Remember, V1 by N1 equals to V2 by N2. Volume and number of moles. At 1, if we are having 1 mole, then it will be 22.4 liters. Volume is given 44.8. N2 will come there. This will be how much moles? Tell me now, how much moles? Very good, 2 moles. Simple, right? So guys, one thing you tell me, from everything you have studied, from everything, so you know that pressure is inversely proportional to volume. This was Boyle's law. Volume is directly proportional to temperature. This was Charles' law. And volume is directly proportional to number of moles. This is Avogadro law. Remember, see. For this one, these things, if you can combine them, so what will happen? See, for this one, you can also write this like volume is inversely proportional to pressure. Simple, no problem. So when I will combine them, I can say that, sir, volume is directly proportional to temperature, okay, also directly proportional to number of moles, but inversely proportional to pressure. Okay, sir, no problem. So what will happen? So this pressure will come here like PV is directly proportional to Tn, and if I will put the constant here, so it will be converted into very famous equation, which is called the ideal gas equation, and also the combined gas equation, which is called PV equals to nRT, where this R is a constant and the value of the constant normally we use is 0.0821 moles per liter. One second. 0.0821 atm atmosphere liter per mole per Kelvin. atm liter per mole per Kelvin. This 0.0821. What does this means? So it means that pressure should be in atm, volume should be in liter, this should be, and this is the number of moles obviously, and the temperature should be in the Kelvin. So this is the combined gas equation. There is also one more equation which comes from here. Let us consider we put the number of moles constant. We only took the temperature and pressure. So it will be converted like PV by T. It will be a constant. And again, what will happen? P1 V1 by T1 equals to P2 V2 by T2. Okay. From where these equation came? From Charles' law, Boyle's law, and Avogadro law only. This one, the equation I wrote in the white box, that is only the combination of Charles' law and Boyle's law. That's it. And for this one, this is called the combined gas law equation. How you will be able to use this? Let me share a question with you. One second. See, we are having a question now. If a child releases 6.25 liters of the balloon, of helium balloon, in the parking lot in the amusement park where the temperature was given and the pressure is also here. See, volume here, temperature here, and pressure here. Okay. What will be the volume? You have to calculate the volume and temperature given and again a pressure given. See, temperature, pressure, and volume, it was given. Volume you have to determine, and pressure and temperature, they are also given. Which formula you will use? You will use the simple formula P1 V1 by T1 equals to P2 V2 by T2. And now everything simple. One thing remember, temperature should be in Kelvin. Very good, Kelvin. Pressure for this equation, okay, for those equation P1 and that side P2, for every that equation you can use pressure and volume of any unit. Like there it is millimeter mercury, you can use mmHg, no problem. Okay, but for the ideal gas equation PV equals to nRT, okay, you will not use that. You will use the ATM, either ATM, or if the millimeter mercury is given, I will tell you how to convert it into the ATM. Okay, so let's move a bit forward. If you want to take the screenshot for this, you can, and you can be able to solve it by yourself. It's not a very what we say, not a very complicated thing. Will you be able to solve it by yourself, guys? Will you be able to solve it by yourself? Is it easy for you? Correct. Yes. Nice. Let's move a bit forward with the another question, which is the ideal gas equation. Okay, and the question is this. I want you to do this. The volume is, you have to calculate the volume. The volume is question mark. Okay, the volume is question mark. I don't know. 1.00 mole, it means the N is equal to 1. Ideal gas at room temperature, the temperature is equal to 25 degrees Celsius, and this atm, it means the pressure is 1 atm. Okay, PVNT. Remember any equation? Which equation you will solve here? Which equation you will use it to solve this question? Which equation will be used? Very good. PV equals to nRT. So PV equals to nRT will be used. Now solve this question, please. Solve this question and tell me what will be the volume of the 1 mole of gas at these things. Yes, R is a constant. R is a constant, and the value of R is 0.0821. The value of R is a constant and the value is 0.0821. Remember this for atm, liter per Kelvin per mole. Yes, you got the answer correct. 24.47 liters. Very good. 24.445 or 47, it's not a problem. It should be 45. That's it. Okay, 24.5. Because if we will do with significant, the answer should be in 3 significant figure and we will round off the answer. So that will be 24.5. So both of you are correct. Okay. So did you understood the question? Did you understood the concept? Okay. Now the concept, the last concept for the today's class, because I don't want to give you a lot of things, a lot of bulk questions. I don't want to do like that. We will study everything, don't worry, but not a rush. Okay, we will do everything with slowly, and don't worry, your syllabus will be finished before 24th, inshallah, with practice and everything, right? So density. In the chapter 1, I know you guys are in chemistry 115. Okay, first when you were in the freshman, you studies STEM, and also in the second semester it was STEM 1 and STEM 2. In everything, STEM 1, STEM 2, and also this chapter 1, it was related to density. So what is the formula for the density? The formula for the density, it is mass of anything divided by the volume. This is the density. Mass over volume. This is density. How I will put density in ideal gas equation? See, we know that PV equals to nRT. Very well. You know number of moles? Remember number of moles? Number of moles is equals to mass divided by molar mass. Mass over molar mass, or the okay. So I will replace this N by W by M. So it will be W by M multiplied by RT equals to PV. Now what I will do, I will just put V below here. So it will be, pressure will be equals to, I will write here, the pressure will be equals to W mass multiplied by R multiplied by T, and molar mass also here, but also by volume, because I put just volume here. See, W by V, mass over volume. What is mass over volume? Density. So for the ideal gas equation, pressure multiplied by molar mass will be equal to density RT. This is also one of the important formula. This is also one of the very important formula to calculate the density. I have a question for you, and this question is also placed inside the ALEX. You know whatever we are doing, they are based on ALEX as well as your final syllabus. Okay, so calculate the density of the carbon dioxide at the room temperature 25 degrees Celsius and 1 atm. We have to calculate the density. So what is the formula? Pressure multiplied by molar mass, it will be equals to density multiplied by R and T. If I want to calculate the density will be equal to PM by RT. Pressure, molecular mass, R constant, and temperature. What is the pressure here? 1. What will be the molar mass of CO2? Tell me, what will be the molar mass of carbon dioxide? What will be the molar mass of carbon dioxide? Very good, 44. Yes, it will be 44. So just calculate. Now tell me what will be the density. Do calculations and tell me what will be the density. Do calculations, guys, and tell me what will be the density. Very good, 1.798, or you can say 1.8. Other students, did you understood this concept? Okay, did you found the density? What value of density you got? What value of density you have got? Okay, 1.8. Very good. What is the unit? Tell me. What do you think? What should be the unit? I told you the density is equal to mass divided by volume. Mass over volume. Mass in gram. Volume in liters. So what will be the unit? Gram over liter. Yani कि gram per liter. Very good. Okay, this is how we will be able to check the units also by using the formulas. Okay, now the next part of this of this chapter, the last part, inshallah tomorrow it will be finished, and we will be able to finish the next part of this chapter for the tomorrow. And if you are having any problem, any doubts, or anything related to this concept, you can ask me on WhatsApp, or you may send any question related to this. Also, Amna, Fatima, and Mahra, so 3 of you, and the others, I think 2 of you are left. You can also send me a small message to remind me that I will be able to send few questions to you for some practice. Okay, just remind me on my WhatsApp. Okay, so inshallah tomorrow, or either evening or in the afternoon, I will be able to send everything. So most welcome, my friends. Inshallah we will have a next session, and I hope it will be continued to complete the syllabus. And thank you so much, and have a great day. Good night.